Assalamualaikum warahmatullahi taala wabarakatuh. So today I'm going to explain on chapter 2, number bases and logic gates, subtopic 2.4, logic gates and application. Alright, so first, so let's go through the learning objective for this subtopic. Okay, now for number 1 is to identify different types of logic gates and the added value of the design. Number 2 is to understand the properties and truth table of each logic gates correctly. And number 3 is to apply the properties of logic gates in multiple combination of the gates. Alright, so first, let's go through the type of logic gates that we are going to learn throughout this subtopic. Alright, so number 1 is buffer. Alright, so buffer, this is the symbol of buffer, which is it has one input and one output. So the truth table is something like this. So A is the input and the Q is output. So for buffer, is the output is the same value as the input. Alright, so number 2 is inverter. Alright, so inverter is very similar to buffer, except for it has dot over here. Alright, so buffer, it has one input and one output. So A is the input and the Z is the output. Okay, for inverter, it has a different concept with buffer, because for output is actually opposite the one that comes from the input. Alright, so for example, when the input is 0, the output is 1. Okay, so when the input is 1, the output will be 0. Okay, logic gates number 3 is AND. The symbol of AND is something like this. Okay, it has 2 input and 1 output. A and B is the input. Alright, so this is the truth table of logic gate AND. So this is the input A and the input B. Y is the output. Alright, for the concept of AND is actually for the output will be 1, both of the input should be 1. Okay, or else it will be 0. Okay, so if you take a look at this one, when the input is 0, 0, the output is 0. Input is 0, 1, output is 0. Input 1, 0, output 0, and the input 1, 1. And of course, the output will be 1. Right? Next is the logic gate for none. None is actually not AND, none, and not AND. Alright? So this is the symbol of none. It has slightly different with AND because it has dot over here. The input, it has 2 input over here, which is A and B. So this is the list of input, and Z will be the output. Alright, so the concept of none is actually it's opposite with the one in AND. For example, when the input is 0, 0, the output is 1. Okay, it's opposite from this one. So for AND, the input is 0, 0, the output is 0. Okay, so for none, the input 0, 1, the output is 1. Different, opposite. Okay, so for input 1, 0, the output is 1, and for the input 1, 1, the output is 0. Next, OR, logic gates OR. This is the symbol of OR. It has 2 input as well and 1 output. Okay, this is the list of input A and B. And the concept of logic gates OR is actually for output to be 1, it's either A or B must be 1. Then the output will be 1. Okay, so for example, when we have the input is 0, 0, of course the output will be 0. input 0 1, it has 1 here, so output will be 1. 1 0, output will be 1, and when both 1, of course the output will be 1. Next, logic gate NOR. Okay, so this is the symbol for logic gate NOR. So for NOR, NOR is basically for not or. Okay, opposite or, not or. Okay, so this is the list of input over here, and the Q is the output. Okay, when we take a look at the table truth for logic gate OR, when 0 0, the output is 0, but it's different for NOR. Okay, for 0 0, it will be 1, because NOR, again, for NOR is actually not OR, it's opposite from the OR. Okay, so for input 0 1, the output will be 0, input 1 0, output 0, and 1 1 will be 0. Next, this is the logic gate for exclusive OR. Okay, this is symbol for exclusive OR. Again, it has 2 input over here, 1 output. Okay, this is the list of input, and Z is the output. Okay, the concept of logic gates exclusive OR is actually for input, the same value of input, the output will be 0. Okay, so for example, 0 0, same value, the output is 0. 1 1, same value, the output will be 0. Input 0 1, different value, so the output will be 1. 1 0, different value, the output will be 1. The last one, okay, logic gates exclusive NOR. This is the symbol for exclusive NOR. Exclusive NOR is actually, or exclusive NOR is X NOR. Okay, it's actually not exclusive, not OR. Okay, so this is A is the list of input A, and B is the list of input B, and Y is actually the output. Okay, so it's basically opposite. The output for exclusive NOR is opposite with output exclusive OR. Okay, so 0 0 will be 1, 0 1 will be 0, 1 0 will be 0, and 1 1 will be 1. Okay, so that's all for